Yeah. On the top end. See how long nice places are for a restaurant. The road place like Brunch. Yeah, there's a lot of it's about big place. Like a restaurant, well, it's like a house, but it's a restaurant. And like it's the only portion of the yeah, that was pretty nice. It's not like super expensive, right? It's good too. It's okay. Like it's not bad. I think the only like that part is that unfortunately we have to pay more about it. Yeah, so unfortunately we have to pay. Yeah. Yeah, I might someone and sell it to them. This guy said he's gonna come and take it off. Yeah. Yeah, because I'm always gonna shop right away. It's just something come by right now. Feel like it's awesome. Yeah, so I have it. It's a really good setup. No, but it's coming. He's in since we buy it. Yeah, if I saw it today, tomorrow, I'll buy it to be like little voice. You know, it's like these videos. That one is kind of yeah.
Yeah. Let's see. After the first midterm, we'll see. It's sort of all based on notes. Or like, it's for the first one. I really just copied exactly. The other one that was straight up and I just not really blocked. Was straight up and it's really I didn't. And I did it, but I didn't do, you know how he does at the end with it completely matches it out? I didn't do that. I just left it open. I just swapped A, B, or A, and then put a sign or whatever. Plus it's not. So I just left it with that approach. He didn't say anything on correction, so.
It's only the weird. In the back, they have like the final seats. No, honestly. They have that, and there's like a little fridge in the back. Yeah. Think about it, no problem, but yeah, I got it. It's like 2, 4. And I have the 2. Yeah, the first one, so. Yeah. Yeah. Cool. Actually, that really. I hear about that. Think so. First month thing yet? Yeah. Yeah. You went to um, it's about it. It's that means. I was gonna say, yeah, I feel like that'd be. Yeah.
What they said. And so they got one.
HP. I just saw someone posting this
Like medication.
like ways to shake and get somebody else asking to pay. Oh, interesting. Yeah.
Knowledge.
You know about it.
Can't eat your food. But it's just.
Someone said it's a month. Swapping for it.
Everybody had a real shout. Just waiting for the.
All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Hanging in there, hanging in there. We're yeah, end of week 4, so I think probably you guys start to have midterms and stuff soon. So things are about to get pretty busy. So we're entering mid-semester form now. So hopefully you guys are taking care of yourselves. Okay, so the plan for today was we're going to finish up our lecture notes on annual cash flow analysis. I have one more example kind of related to what we did last time. But for the most part today, we're going to be talking about something called an amortization schedule. Okay? And it's all about how to organize payments on a loan. And so, a little bit of a sidetrack, not super related to what we're doing, but kind of, in the same vein. If as long as we're here doing annual cash flow analysis, it'd be good to go over that. This is kind of more of a life skill more than anything than what we're doing in this class. So yeah, that's the plan for today. I don't really have any announcements. Are there any other questions I can answer before we get started for today? Okay. All right, so let's go ahead and continue where we left off. And so this whole week we're talking about annual cash flow analysis. So annual cash flow analysis, just like we talked about on Tuesday, is kind of the close cousin to present worth analysis. So the idea with this technique here is to systematically and kind of consistently choose the best economic alternative, either one that minimizes costs, maximizes the benefit, whatever. Okay. Okay. Like we've mentioned, one thing that you'll be doing a lot if you're managing budgets and you're choosing vendors and things like that is you're going to be choosing between lots of different options, and you want to make sure that you have the proper techniques or the proper tools to choose the best one possible, right? And of course, the main thing that makes this task difficult is the idea that the value of money changes with time, with interest rates, with inflation. And when you're planning a project that's going to take over a long period of time, you need to take that into account. And so that's why we have these techniques. Okay? And so the main way that we accomplish this through annual cash flow analysis is to take all the cash flows associated with the given project or with the given option and convert it to a uniform series. Okay. And uniform series, remember, we give that the symbol A. Okay. And so, of course, this involves using our formulas, more often than not involves using our compound interest table, okay? In order to do that. So last time we talked on Tuesday, we did a couple of examples of this. Most notably, what we observed was that, when you have options that have different product lives, doing annual cash flow analysis makes it a little bit easier to do because you don't have to find the least common multiple. Because you remember, when we did that in present worth analysis, we were comparing two options. Let's say one option had a product life of 6 years, another product had a life of 12 years, right? We had to extend this analysis to the least common multiple, which would be 12 years, right? But with annual cash flow analysis, because it's naturally a recurring type of cash flow, you don't have to do this. Granted that you can make some assumptions, such as, you plan on buying replacements, whenever they come up. Okay. But it's definitely a nice perk because it's a lot of times, more often than not, it simplifies your analysis quite a bit. Okay. We're going to build on this, and we're going to combine this together with the idea that we talked about, at the end of the present worth analysis, which is capitalized costs, right? And so what I mean by this is that, we're going to use annual cash flow analysis to analyze products with an infinite useful life. Because you remember we talked before that, there are a lot of engineering projects that are basically assumed to be, maintained infinitely, right? A lot of public works projects, roads, stoplights, traffic, or sidewalks, these are all things that need to be maintained for forever. Okay. And so the question is that, if you have such a project, how do you perform, or how do you analyze it from an economic perspective? And so if something is meant to last forever, that means the value of n, or the number of time periods, is infinity, right? And so if you were to compute, the EUAC of such a situation, right? And if you were to use the tables, okay, it would look something like this, right? And so whatever, in this case, I just have a single present sum. But if we were to convert that to an infinite, an infinite uniform series, we'd have to put infinity here. And of course, infinity does not exist. There's no such entry in the compound interest table. Okay. Okay. And so the way that we approach this analysis has to be a little bit different. Okay. And so here, the way that we obtain our equivalent uniform annual cost, or equivalent uniform annual worth, is to make use of our idea of a capitalized cost. So if you recall from the beginning of lecture on Tuesday, what we were discussing this idea that if you have a very large sum of money, present sum, okay, and if you were to invest that and basically just collect on those investments each year at a certain interest rate, then you would obtain essentially a uniform series, right? Where that uniform series amount would just be your present sum, your large capitalized cost, multiplied by your interest rate. Right? So this would be your capitalized costs. And this right here will be your uniform series. Okay. And so if you're doing analysis for a certain option or a certain project where either, it tells you or that this project has an infinite useful life, or another word that's often used is permanent. Okay. And so if a project is meant to be permanent, then you can use this to obtain the equivalent uniform annual. Okay. All right. So it's pretty straightforward. So let's just do an example really quick. Okay. And so let's say that a certain city is considering an expansion to their aqueduct. Okay. And of course, there are two options that they're considering. All right, so an aqueduct is basically it's part of the infrastructure that's used for water storage and water transport within a city. Okay, so very much a public works project, something that's going to benefit the entire public. Okay. Okay, and so the problem with this planned expansion is that there is a gigantic mountain that's kind of in the way between the water source and where it needs to go. Okay. And so the project that must be undertaken is how to deal with this, how to get the water around or through the mountain. Okay. All right. So the two options is, maybe first option is to tunnel through the mountain. So this would be basically option A. Okay. So tunneling through the mountain has a initial cost. So I'm gonna go ahead and make a table for this. So initial cost. Tunneling through the mountain has an initial cost of $5.5 million. So it takes a lot of money to tunnel through a mountain, right? So it takes a lot of work crews and things like that. But once you kind of tunnel through the mountain, the mountain itself kind of acts as a nice insulation to kind of protect the tunnel. And so for all intents and purposes, minus minor maintenance, which for this problem we're going to neglect, the tunnel through the mountains has a useful life of infinity. And so this tunnel was going to be permanent. The other option we're considering is to go around the mountain, and so this would be to build a pipe. Okay, so this would be like option B. So going around the mountain will take a lot less demolition, right? So you don't have to, dig through a mountain. So your cost here is going to be slightly cheaper, although still quite expensive. Okay, so going around the mountain, we're going to imagine that it takes a lot of piping to go around. Our initial cost in that case is going to be $5 million. Right. But because this pipe is going around the mountain, it's exposed to kind of the elements. If rain hits it, so this pipe is going to have to be replaced every now and then. And so the useful life, it's estimated to be about 50 years. So every 50 years, that entire pipeline has to be replaced. Okay. All right. And so if we assume an interest rate of 6%, let's use annual cash flow analysis to determine which is the better option. We have two options here. One is a little bit more expensive, but for all intents and purposes, that option is permanent. It's going to last forever. And then we have the other option that's slightly less expensive, but we do have to replace it every 50 years. Okay. All right. So this is a situation where I think at first blush, you would look at these statistics, and you would say that all we have to pay is just $500,000 more. That's about 10% more, and we get an option that's permanent, one that's going to last forever, right? So it seems like that for most practical people, that option A is the better option. Okay. But going with option B, 50 years is still a long time, and going with option B lets us keep $500,000 today, right? Which is not negligible. So that's still quite a lot of money. And so, let's go through the analysis and see kind of which one is actually better. Okay. All right. So since we're doing annual cash flow analysis, what we're going to do is we're going to compute the equivalent uniform annual cost. We're going to compute So we're going to compute the EUAC for both options. Okay. Okay, so let's start with option A. So option A has an infinite product life, right? And so we can't analyze this using the compound interest tables. So if we can't use the compound interest tables with an infinite life, let's make use of our capitalized costs. Okay? And so the EUAC of option A, okay? We know our interest rate is 6%, so we're going to take 0.06, okay? And we're going to multiply this by the initial cost, okay? That is a present sum. So that's going to be minus 5.5 million. I'm making it negative because it is a cost, okay? And so when we multiply this out, we get minus $330,000. Okay. So that's the equivalent uniform annual cost for option A. Let's do option B. So this one does have a finite product life. This one only lasts for 50 years. And so for option B, we can use our compound interest tables. Okay, so the EUAC option B. Okay. Our initial cost for option B is $5 million. We have minus 5 million. Okay. That's our initial cost. And so we need to convert that to a uniform series. And so this is going to be an A over P. Interest rate is 6%. And our N here is 50 years, okay? All right, so since we have a finite product life here, this is something we can look up in the tables. And so once we plug this in, I don't have the exact conversion factor here, unfortunately, but that one you can look up in the tables. And so what we get from this is minus 317,000. Okay. Right. And so based on these results, we can see which is the better option. A little bit of a surprising result, right? And so in this case, where we're only considering the costs, we want to choose the option with less equivalent costs, right? In this case, it's option B. Yeah, a little bit surprising, right? So you would think the one which is permanent would be the preferable option, right? And so it's only you spend 10% more, but then you're able to get something that you never have to worry about in theory, right? But when you think about it from this perspective, it's not that surprising. And so going with option B essentially saves you $500,000 today. And remember what we've always talked about, that, money that you can have presently is always going to be extremely valuable, right? Because what can you do with that money? You can take that extra $500,000. So, the fact that you were considering these two options to begin with means that the city has given you a budget of 5.5 million at least, right? And so you can take that extra $500,000 and you can invest it. Okay. And we're already given the interest rate in this problem. We're given that the interest rate is 6%. Okay. Of course, the caveat with option B is that eventually you're going to have to replace the pipeline, right? So in 50 years, you're going to have to replace it. But what this is telling us is that if we take that $500,000, we invest it at a yearly interest rate of 6%, then over the course of 50 years, this is going to pay for the replacement and then some. Okay? So you see this a lot of times. And so you see that, whenever you have the option of taking kind of more money at the present, that's usually going to be better because it gives you a lot more flexibility, a lot more, options with what you can do with that money today, rather than kind of locking it up in a long-term project like this. Okay. All right. Any questions on this example here? Okay. All right. So let's go and move on to the next thing. And so the last thing I want to talk about for annual cash flow analysis is this concept called an amortization schedule. And this amortization schedule is basically a tool that you can use to analyze a loan. Okay. So I put this topic here with annual cash flow analysis because, remember what annual cash flow analysis represent. It's an annual cash flow is basically a recurring type payment that you're making on a regular schedule, right? And so the most common situation that most people do for this is to repay a loan. And so an amortization schedule is basically a tool that you can use to analyze your payments. Okay. Because a lot of times when you're taking out a loan, like the loan is given to you at a particular interest rate, right? And what that interest rate basically says is that you're going to pay extra eventually, to use this money. Okay. And so to look at all your payments and see, how much of your payment is going towards the original loan amount, which is the principal, versus your interest, can be helpful. And an amortization schedule kind of lays all this out for you. Okay. I just learned this recently, but I just learned that there are actually tools in Microsoft Excel, and I believe in also online spreadsheets too, like Google Sheets, to kind of build one automatically for you. Okay. So we're gonna go over, assuming that you don't know how to do that, and so we're gonna learn how to build one up from scratch. But then of course, having this knowledge is going to help you interpret when you see this data as well, because once you kind of and maybe some of you are already doing this, but at some point in your life, most likely you're going to borrow money for something. That's just how it is to do stuff. And so to be able to do your own analysis for this and to kind of check everything yourself is always going to be a really useful skill, a really useful life skill, because there's a lot of people out there that are want to take advantage of people. Okay. All right. So the basics of an amortization schedule looks like the following. Or at least the one that we're going to be using in this class. And so for this class, I kind of split the schedule up into two sections. So there's kind of a header section, which kind of has just basic information. Okay. And so in the header section, we have things like the initial balance. So the initial balance is how much money that you're taking loan out for. Okay. Okay. We have our interest rate. Okay. You have your number of payments. And then you have your payment amount. Okay, so the payment amount is how much you're paying, whether it be every year, every month, so on and so forth. Okay. So that header section there is just to kind of give you just the stats for the loan, just kind of at a glance, right? These four pieces of information are the most basic things that you need. Okay. And then the second part here is an actual table that kind of breaks down each and every single payment. All right, so I'll write out all the columns here and then we'll go over each one. Okay. So these are all the tables for your amortization schedule. And so the first column here, which is the period, So that just tells you in which pay period that you're in. So this is just a sequential list. We have 1, 2, 3, all the way up to the however many payments that you have. Okay. All right. So the beginning balance, we'll go through each of these columns and kind of define them individually. Okay. So the beginning balance is how much you currently owe on the loan at the beginning of that pay period. Okay. Another way to say that is that this is the current present day value of the loan. All right, so the interest, this column here isn't referring to the interest rate. That's already given at the beginning, above the table. The interest is how much of your payment is going towards paying off interest. Okay. And so in some ways you can almost see this as like, waste is not the waste is not the right word, but what you'll see that for every pay period, however much you pay, only a certain percentage of that is going towards paying your balance. Okay, the rest of that is going to pay towards the interest. Okay. So this interest column is the amount of interest owed in this period. And the way you compute this is you just take your whatever beginning balance you had in the second column and you multiply it by the interest rate. Okay. So this is equal to beginning balance multiplied by I. Okay. And that I, of course, has to be in decimal form as well. And we'll talk about the interest rate I in a little bit as well, because there are some wrinkles that are associated with this as well. Whether you're given your interest rate as a yearly interest rate, that's usually most common out there in the world. It's given to you in the form of APY. But usually a lot of payments on loans are done monthly, and so you have to do a little bit of conversion there to get the right interest rate. Okay, we'll go over that in a bit. Okay, principal paid. All right, so once the interest is taken care of, whatever money that's remaining in your payment goes towards paying off the principal or paying off your balance. So to compute this is quite simple. So to compute this, you take your payment amount. Okay, and you subtract the interest. Okay. So the payment amount that you're making in each period is going to be the same. Okay. And so, once you subtract the interest is paid off, then whatever you have left goes towards your principal. Okay. All right. And then the last column here, the ending balance. The ending balance is just, after you made your payment towards the principal. Okay. The ending balance is however much you have left to pay off on the loan after this pay period. Okay. All right, so those are all the columns of the amortization schedule, and we'll do a couple of examples, kind of filling these out just so that you have an idea of how to fill them out. Any questions on this so far? Okay. All right, let's discuss how do we actually compute the payment amount. All right, so remember, when you pay off a loan, you're doing that with uniform payments usually, right? And so your loan payment amount is going to be, converting, basically you would just convert your loan balance into a uniform series. Okay. And so your loan amount A is equal to P multiplied by A over P interest rate N. Where P here is the initial amount on the loan. Okay. So usually when you get a loan, that's money that you get in the present day. Okay. And then you multiply it by the corresponding conversion factor. And so, we're bringing in our compound interest table into this thing as well. Okay. Okay. Let's talk about the interest rate a little bit because this can be a little bit confusing, when you're first using this. Okay. All right. So when you are plugging this into the compound interest table, you need to be a little bit careful about the interest rate that you're choosing. Okay? Okay. And so the interest rate that you use for this conversion or that you use for this calculation should match the frequency of the payments that you're making. Okay. So like I mentioned, for a lot of commercial loans that you're going to take out, payments are usually made monthly, right? So you make a payment on the first of every month for your loan. Okay. Interest rates, on the other hand, are usually not given to you in terms of a monthly interest rate. Okay. So for example, I'll give you the most common example that's used a lot. And so the most common example of this is that interest rates are often given to you in terms of a form called APY. Okay. So APY, if you're curious what that stands for, it's an acronym. It stands for annual percent yield. Okay. You may have heard another term, APR. APR is essentially the same. APR is annual percent return. There are slight differences, but usually they're technically different. They're different things, APR, APY. But for most cases, the actual numerical difference between them is very negligible, unless you're talking about massive interest rates. Okay. So an APY is a yearly interest rate. So that's how much interest you're going to earn for the whole year. But that doesn't translate to the month. And so to translate this to a monthly payment, you need to take this APY and divide it by 12. Okay. And so in that case, your interest rate is APY divided by 12. That's the interest rate you should look up on your compound interest table, okay, not the APY. Because if you plug in the APY, and you're doing a monthly payment, you're going to end up with a payment amount that's way higher than than what you should be paying. Okay. All right, so just be careful about that. And oftentimes, you have to kind of read the fine print very carefully about kind of what interest rate that they're giving you. Okay. Okay. Any questions on this? Okay, let's do an example to kind of see how this all kind of comes together. All right. So let's say that you just moved into a new place and you need to buy furniture to furnish the apartment. Okay. And so you go to living spaces, you purchase a new couch or something, you buy a new kitchen table, and the purchase will cost you $2,400. Right, and so so the store has a financing option, and so just to kind of save yourself, so you don't just take a huge hit to your bank account right away, you decide to finance this purchase over the course of 4 months. So you're gonna do this in 4 equal payments over the course of 4 months. Okay. Of course, the financing isn't free, and so they are going to charge you an interest rate on this. Okay. So the store will charge and so the store is going to charge a monthly interest rate of 0.25%. So quite modest, and so not too much to worry. Okay. All right. So for this problem, we want to do 2 things, and so for the first thing we want to do is we want to compute the payment amount. Number 2, we want to build the full amortization schedule. Okay. All right. So let's start with the payment amount. Okay. So we have our initial balance here. So our initial balance is 2,400. We have our interest rate, and in this case, the interest rate that's given to us is a monthly interest rate, so that we don't have to do any conversion, right? We don't have to divide by 12. And we're given the number of payments, which is 4. Okay. So we have all the information we need. And so if we compute A is equal to 2,400, A over P, interest rate is 0.25%, and the number of periods is 4. Okay. So luckily, 0.25%, that there is a compound interest table for that. I think it's the very first one that they have. It's the smallest interest rate. But of course, if the interest rate that you have is not in the table, you can always just use the formulas to do it, okay? In this case, you know, the calculations are not that bad, it's just one conclusion. All right, but for this case, we do have a table value for this. And so for this, our table value is 0.2516. Okay. And so that tells us our payment amount, A, is equal to $603.84. So each month, for 4 months in a row, you're going to pay the furniture store $603.84. Okay, so now let's build the full amortization schedule. Okay. This one's fairly small. There's only 4 payments, so our table here is only going to have four entries. Okay. But just know that in reality, you know, a lot of these schedules are massive, right? Especially if we talk about the mortgage. Typically, those mortgages are 30 years or 12 months, right? And so those are kind of, you know, hundreds of lines long, but this is only 4 months. So, okay. So let's build the top portion of the schedule. And so let's go ahead and fill in the initial balance. Interest rate. Number of payments. And then also the payment amount. Okay. So we have all this information. This was either given to us in the problem, or we literally just computed it just a couple minutes ago. Okay. So our initial balance is 2,400. Our interest rate in this case is 0.25%. Of course, you know, just because it's going to be useful for us to build the table, let's go ahead and convert this to decimal form. And so in decimal form, this is 0.0025. The number of payments in this case is only 4. And the payment amount, which we just computed, is $603.84. Okay, now let's start filling out the table. So let's go ahead and make all the column headers. All right, so we have the period, we have the beginning balance, interest amount. Next column is the principal paid. And the last column is the remaining balance. Okay, so let's do the first row together, just so you can see how each row is each column in that row is computed. Okay, and then from there, you know, we'll kind of fill out everything sequentially. Okay, so the beginning balance in period 1, we haven't made any payments yet. And so we're going to start with the initial balance of the loan, which is 2,400. Okay. Our interest payment for period 1. Remember, the way that we obtain this interest payment is we just take the beginning balance and we multiply it by the interest rate. Okay. And so our beginning balance in that period is 2,400. And then we're going to multiply our interest rate, which is 0.0025. Okay. In decimal form. So that means the amount of interest that we pay is $6. Okay. Okay. Now let's do the principal paid. All right, so remember the principal paid, and so in the first month there, we know that we're going to pay $603.84. Okay. Our principal paid, we're going to take $603.84. Okay. And we're going to subtract the amount of interest that we paid that month. Okay. So we do 603.84 minus 6. And what we get from that is $597.84. Remember, the payments that we're making each month is fixed. And so the payments that we're making each month is $603. Okay. A certain percentage of that is going to go towards the interest. A certain percentage of that is going to go towards the principal. Okay. Okay, so our remaining balance now is going to be whatever our beginning balance was. And so at the beginning of period 1, our beginning balance was 2,400. Okay. From that, we're going to subtract our principal paid. And so our principal paid in the first period is 597.84. Okay. And so we do that subtraction, and what we get is $1,802.16. Okay. Our remaining balance here is 1802.16. Okay. All right, any questions on how we got those numbers there? Okay. All right, and so that's basically how you do this. And so from here, it's just kind of repeating those same calculations over and over. So this is one of those things where doing this by hand is definitely more annoying than than it's worth. And so if you're good with the spreadsheet program, you don't even have to use the automated tools. And so you can just set up the equations in each of these columns, and it'll do it all kind of eventually for you. Okay. All right, so let's go through each of the other rows of the table here, and we'll kind of go a little bit more quickly this time. And so at the beginning of period 2, okay, our remaining balance is just what our beginning balance is whatever our remaining balance was in the previous year, okay, or previous month. And so it's going to be 1802 and 16 cents. Okay. Right. Our interest payments in the second period is going to be 0.25% of this new beginning balance. Okay. And so we take 0.0025 and multiply by 1802. What we get is approximately $4.50. Okay. Notice how the interest payment in the second period went down. That's not a coincidence. We'll talk about that in a second. Okay. Our principal paid is going to go up because our interest rate, or not our interest rate, our interest payment went down. And so our principal paid in this case is $599.34. And then we subtract that from the beginning balance, and what we get is 1202 and 82 cents. And I'm going to bring that remaining balance in as the beginning balance of period 3. 1202.82. All right, so let's go through this whole thing one more time. So our interest is going to be 0.25% of that 1202. This is about $3. Okay, round it a little bit, just to keep things simple. So our principal paid is going to be $600.84. Our remaining balance is about $601.98. All right, and so we start our last row. So our last row has a beginning balance of 601.98. The interest is going to be $1.50. Our principal paid in that month is going to be 602.34. Okay. And so if you did everything correctly at the very last row of your table, you should end up with a remaining balance of $0. Okay. All right. That's what should happen if everything kind of works out. But what you'll see is that, especially when you do this for homework, because of rounding and because of kind of numerical kind of round off error, you may not get a remaining balance of exactly zero at the end. And so maybe a few cents and maybe a few dollars. That's okay, especially for the bigger tables that, bigger tables that are 12, 15, 20 rows long. All of those roundup errors will kind of catch up to you at some point. And so this example, it worked out where we ended up basically with exactly $0, but you may not end up with exactly $0 when you do this yourself. Okay, but that's okay. It doesn't have to be perfectly exact. Usually any kind of extra money that's owed gets rolled into the last payment or something, but it's usually kind of a small, a relatively small. All right, any questions on this? Okay. All right, so for the last 20 minutes of class today, I do want to point out a few things here from this table. All right, first thing you should notice is that as you get further and further along into the loan, the interest payments go down. Okay. So mathematically, you can see why, right? Because usually for these loans, the interest rate is fixed. But with each payment, your amount of principal or remaining balance is going down. So this is very common, and I mean this is just kind of what happens naturally. And in fact, for some of the bigger loans where you're making a few hundred payments, like a mortgage loan for instance, okay, this kind of gets to the extreme, and so and it's a little bit depressing to look at, honestly. And so for some of the bigger loans. And just note that, no matter how big of a loan that you're getting, no matter how high your interest rate is, you're never going to go backwards in a loan, right? So there's always going to be, whenever you make a payment, at least some of that is actually going to be paying off the loan, per payment. Okay. But for some of the bigger loans where the number of payments are higher. Okay. And so in some of these bigger loans, right, if you see the breakdown, and so if you were to use this table to break down like a mortgage payment, you'll see that depending on your interest rate, depending on your depends on a lot of things, But sometimes it could be upwards of like 99% of your entire payment is going towards the interest, and only 1% of your payment is actually going to repay off the loan, which is very it's very depressing to see sometimes. Um, a little bit of story behind it. Um, my wife didn't know this, and so when I kind of showed her the math of this and how it worked, she got really depressed. And she's like, "Why even borrow money at all? This is the situation." I'm like, "Babe, that's just how it works, you know." Eventually, you will be making bigger payments towards the principal, but for the early stages of the loan, it's not like that. And so, in terms of a mortgage, right? And so if you were to buy a home, the common advice that people tell you is to, if you're going to buy a home, you should hold on to the home for at least 5 years before you think about reselling it, right? And this is the main reason behind that, because, for the first 5 years, you're not really making any payments on the loan itself. And so you're mostly just paying interest at that point. And so if you were to sell your home, you basically would just get your down payment back. You wouldn't really get any equity back. So it's only after the 5 year mark that's when you really start to build equity and pay off the loan and really start to feel like you own your house. And so that's a very common thing with these loans. Okay? On the flip side, if your interest payments are going down as the loan progresses, that means your principal payments are going up. Okay? And so as you get into the later and later stages of the loan, your amount that you're actually paying off the loan with is going to go up. Question, yes.
Doesn't this also mean the opposite? Like if you miss a payment, your interest amount is only gonna go up?
So if you miss a payment, usually the banks have a policy on that. Usually they kind of put a pause on the interest at that point. You have to pay a fee, of course. And so the fee will kind of add on to the overall amount that you pay. But they don't tack on the interest of a payment that you miss and add that to the next one. Usually they just add on the fee to that. But the exact policy depends on the bank. Mhm. And so if you were to graph this, I like graphing things because I'm generally a pretty visual learner. Okay. Okay, and so on the horizontal axis here, we have time. Okay. Generally, you have this kind of two things that are kind of two lines that are crossing each other. My brain farted for a second. Okay. And so generally over time like this, the amount of interest that you're paying is going to go down. Whereas your principal payments are going to go up. It may not have that exact shape, generally, it's accelerated more towards the end. But they kind of has this kind of rough shape. Okay. And remember, your principal payments are never going to be negative, or they're never going to be zero. And so the amount of payment that you have that you computed using the compound interest tables, this amount always ensures that you're going to be making some progress towards your principal every payment. Okay. And so you're never going to be in a situation, you may be in a situation where, maybe 99.9% of your payment's going to go towards the interest. But you're always going to have, at least 1 cent of your payment is going to go towards the principal. Hopefully you're in a better situation where it's more than 1 cent. But there's always going to be some progress that's being made. Okay. All right. Any questions on this so far? Okay, last thing I want to cover today, and I think we'll end a bit early. Another useful thing to learn about loans is to, let's say that you've had a loan for a while now, you've made several payments, and you want to find out just very quickly what's your remaining balance on the loan. So of course, one way to do this is to build the full amortization schedule and then kind of look up what row you are on the table and read it off there. But that's a little bit cumbersome, and there's a much easier way to do this. Okay. All right. So one way to compute this, or one way to to know this very quickly, is to think of this as this is the current value of the remaining payments. All right, and so for this, we're essentially computing a p-value, and so we're gonna get the compound interest tables involved here. Okay, and so to compute this, you're gonna take your uniform payment amount A, and you're gonna convert it to a p. Okay, so you're gonna do a p over A. We're gonna plug in the interest rate. Okay. But you have to be a little bit careful about the n that you plug in here. Okay. Because the n that you plug in is not going to be the total number of payments you're making on the loan. That's how you would do kind of the original calculation. But instead, you're going to plug in the number of remaining payments you have left. So let's say, from the last example, let's say that you've made a payment, you made 1 payment on the first month, and you want to find out how many payments or how much you have left on the loan. Okay. In that situation, you would have 3 payments remaining. So 4 minus 1 is 3. And you plug in 3 there. You plug in your payment amount A. So this A here is your loan payment amount. And you use a P over A factor from the compound interest tables to get this amount for you. Okay. All right. Any questions on this? All right, so that's all I got for today. So we'll end a bit early. So when we come back on Tuesday, we're going to start a new unit called rate of return analysis. And so rate of return, a little bit different than present worth and annual cash flow, but it's still used in kind of the same context. So look forward to that. All right, so thank you guys for coming today. Hope you guys enjoy the rest of your day. Hope you guys have a good weekend, and I'll see you all on Tuesday.
Thank you, Professor.
No problem. See you guys.
What are you planning on doing over the long weekend?
It's a long weekend.
Yeah.
I didn't even realize it. I don't know. Now I have to think about what I want to do.
Something to think about, at least I ran.
You're right. I've been hearing a lot of advertisements about President's Day
Yeah,
sales, and so,
President's Day.
yeah, you're probably right. I'll think about it.
It's classes on Monday.
I don't, that's why, but I do advising on Mondays usually, so. Yeah, maybe I'll cancel my advising, although it hasn't been that much lately, so. You too. See you guys. You guys,
I had one question.
sure.
About homework, it's 1D.
Yep.
And I looked through the notes, I did like I take the notes on here, I did like a command F, I still couldn't find the word endowment.
Yeah. So endowment, that has to do with a capitalized cost. And so if you kind of look, just university endowments in general, it's like a large pot of money. And then usually what they're supposed to do is like, they're supposed to invest that money and then take the interest and then use that to support university functions. That's the idea. Doesn't quite work out that way a lot of times. They kind of just like, oh, money, we'll just keep it. But that's what they're supposed to be for. So it's about that idea of capitalized costs.
Cool, thank you.
Yep.
Have a good one.
You too.